Okay, so chapter 4 review is going to be done in 2 parts mainly because the content of chapter 4 is not really difficult, but it does take a longer time to explain. So if it's something that you're not remembering, I have to explain that in a lot more detail. So doing this video in 2 parts just to cut back on some of that video length and hopefully that upload time. Okay, so we began this chapter with factoring. So we would factor numbers such as, if I had 28, it would ask me to write all the factors of 28. And a factor, remember, is all the numbers that I can divide 28 by that do not produce a decimal. So when I take 28 and I divide it by a number, I get another whole number. Those are the numbers I'm looking for. So I'm going to think about all the numbers that 28 can be divided by. And I'm going to start with the very first number, which is 1. And yes, 28 can be divided by 1. In fact, any number can be divided by 1. Then I'm going to ask myself, can 28 be divided by 2? Yes, 28 is an even number. Any even number can be divided by the number 2. If I'm thinking about this, 1 divides 28 times, which means 28 can also be divided by 28. So that is a factor as well. 2, how many times does 2 divide 28? I can divide 28 by 2. That goes in 1 time. Bring down the 8. That 2 into 8 goes 4 times. 4 times 2 is 8. So 8 divided by 2 is going to be 4. That probably sounded really confusing. And that's going to be the end of that. So yes, 2 divides 28 equally. I ended with a whole number up here. So that's how I know that both 2 and 14 are factors. So I'm going to put this on the higher end. Then I'm going to say, does 3, can I multiply? This is one way you can ask yourself about factors. Can a number multiply by something to get 28? So 3, I'm thinking about my factors for 3, and there's nothing that I could multiply 3 by to get 28. So that means 28 is also not divisible by 3. 4, is there something I can multiply 4 by to get 28? The answer is yes. If I'm thinking through my facts, I know that if I take 4 and I multiply by 7, I will get 28. And then I just kind of keep going until I meet the numbers on this side. So 5 would be next. It does not end in a 0 or a 5, so it is not divisible by 5. That's one trick that we've learned. 6, I'm thinking about my facts for 6, and there's nothing that I can multiply 6 by to get 28, and that means that 28 is not divisible by 6 as well. And then I'm back to 7, which I already know is a factor. So this is my list of factors for the number 28. I always try to go in order, starting with 1 and then bringing it over to the bigger side. And I know some of you made like these rainbow type things. That was new to me this year. You showed me that one. And then that kind of helps you keep track of the factors as well. So just to recap, factors are simply listing the numbers that divide a number that is given to you. Then we went into prime factorization, and remember that the word prime means numbers that can only be divided by the number 1 and itself. So for example, 5 is a prime number because the only factors of 5 are 1 and 5. 2 does not divide 5, 3 does not divide 5, 4 doesn't. It's only these 2, 1 and 5. That would be a prime number. So just to recap, prime number is is a number whose factors are only 1 and itself. So example, there's thousands more prime numbers. Prime factorization is a process. There's two methods that we learned this year, so I'm going to kind of split the marker board down in half so you can see them side by side. And I'm going to start with your favorite, or at least what I thought was your favorite at the time when we were doing these, the prime factorization tree method. So this is when we simply list factors of the number given, in this case 72, and figure out which ones of the numbers listed are prime. So I'm just going to start with two numbers that when they are multiplied together equals 72. And I'm going to start with 8 and 9 because I know 8 times 9 is 72. And I can even put a little multiplication sign in between there. I need to ask myself, is 8 prime? No. There are still more numbers that I can divide 8 by. And those numbers are 4 and 2. 4 is a factor of 8, 2 is a factor of 8. Is 9 prime? No, it's not, because I can divide it by 1, I can divide it by 3, and I can divide it by 9. So, more than 2 factors equals not a prime number. 3 times 3 is how I would get to 9 here. 2, is that prime? Yes, 2 is a prime number because I can only factor a 1 and a 2 out of it. Is 4 a prime number? No, we know that we can divide 4. We can break it down even smaller. We can break this into 2's here. And 2, of course, is prime. 3 is prime because I can only divide it by 1 and 3. 1 in itself. So there are all the prime numbers that occupy 72, basically, when I prime factorize this. How many 2's do I have? I have 3 2's, so 2 to the power of 3. And if I multiply that, remember this dot means multiply, if I multiply that by, I have 2 3's here, so 3 to the power of 2. Why to the power of? Because I'm multiplying the same number together. So this is 3 times 3. A fancy way of writing that is 3 squared, or 3 to the power of 2. Same with the 2's. I have 3 of them all being multiplied together. When I multiply this out, I will get 72, which brings me back to the top here. 2 to the third is 8. 3 squared is 9. 8 times 9 is 72. The next method we learned that was new, but I know some of you really liked doing this method, was the ladder method. And the ladder method is when you keep dividing prime numbers only out of the number that is given. So I'm going to start with the number 3 because I know 3 can go into 72 and 3 is prime. 3 can go into 72, let's see, 3 into 7 2 times, and then it would be, I'll just write it out so you can see as well, subtract. So then it would be, how many times does 3 go into 12? That goes in there 4 times. So now I need to think of what prime number could divide 24. I'm going to use 3 again because I know 1, 3 is prime, and 2, it goes into 24 equally. 24 divided by 3 is 8. Prime number that divides 8, 2 is a prime number that divides 8. When I take 8 and divide by 2, I get 4. 4 can be divided by the prime number 2. 4 divided by 2 is 2. And the last one, 2 divided by 2 is 1. When using this ladder method, if we end with 1, we know that we are done. That kind of rhymed. I have 3 2's, so that's 2 to the power of 3. And I have 2 3's, that's kind of like a tongue twister. 3, sorry. 3 to the power of 2. So you can see I got the exact same thing. Either method works fine. You get to choose which one you like the best, and I hope I did a good enough job explaining that to you. Alright, then we went into the greatest common factor, and this is going to be the last thing I do on this part of the video. And we learned like 3 methods as well for that one, but I'm only going to do 2 in this video because that should get the job done for you guys. Plus it can be overwhelming, especially if you don't remember how to do this, to like relearn 3 methods in a short video. So the first method, when we're finding the GCF, remember the GCF stands for the greatest common factor. So we're taking 2 numbers in this case, and we're asking ourselves which factor, when I factor these out, which number do they have in common, and which number is the greatest that they have in common. Alright, and I chose the number 16 and 40 for this one, and I'm trying to find the GCF, for the greatest common factor. So step 1 that some of you might like to do is just factor them out like we did at the very first part of this video. I'm going to start with 1 because 1 can go into 16 times. 16 is an even number, so I know that I can divide it by 2, and when I do that I get 8. Can 3 go into 16? No. How about 4? Yes, and 4 can go 4 times. So that is my factorization for 16. 40. I know 1 can go into 40 times. I know 2 can go into 40 because it's an even number. It can go in there 20 times. 3 into 40, probably not. 4, yes, 4 can go in 10 times. 5 can go in to 40 8 times. And then let's try 6, no, 7, no, and then we're back to 8. So this is my factorization, or the factors of 40. Now I need to look. Oh, they have a 1 in common. They have a 2 in common. They have a 4 in common. No 5. 4 in common. They have an 8 in common. And that's it. So then final step here is to ask which one of the numbers they have in common is the greatest or the biggest. And in this case, 8. So the GCF here, the greatest common factor, is going to be 8. You guys can also use the tree method to help you solve this one as well. So if I do 16 and 40, break this down into its prime parts here. I'm going to get, when I write this out, if I don't write it as with this exponent, if I just write it out in expanded form, it looks like this. 2 times 2 times 2 times 2. And this one then would be, let's do 4 and 10. 5 and 2. These are both prime numbers. 4, 2 times 2 prime numbers. And I'm left with all prime numbers, so now I know I'm done. Write that underneath. So this was for the number 8, and this is going to be for the number 40. 2 times 2 times 2 times 5. So I used all of these. Have them all written here. Now which ones do they have in common? They have this set of 2's, this set of 2's, and this set of 2's. These are not the same. So I have 2 times 2 times 2 in common here, which when I actually multiply that out, 2 times 2 is 4, 4 times 2 is 8. And if you notice, we got the same thing on both sides. This way is a little bit more accurate, especially if you have really big numbers. This is more the way to go because you can get really lost listing all the factors. You might miss something using this method. But when your numbers are smaller, this one is a really great method to use as well. So that's it for Chapter 4 Review Video Part 1.